7, synthetic division. So today you should learn about synthetic division and the remainder theorem, and also how to use the remainder theorem to evaluate polynomials. They're related, synthetic division, the remainder to the remainder theorem. But let's start with this one. So like before we were dividing, but in this case we're gonna use synthetic division. I think it's easier way how to divide. So they're giving you this polynomial and they want you guys to divide by this. But in this type of question, this is what you're gonna do. So you're gonna draw a line like that. And then here you're gonna put the coefficients of this polynomial. So the coefficient is 2, -1, -13, and +1. Those numbers you're gonna put here. So 2, -1, -13, and +1. So that's the first step. Coefficients of the polynomial, you're gonna put in like that here. And then here you're gonna put the c of the divisor. So this is the x minus c. So c for this divisor, c would be +3. It's always, and this is, you will have to remember, it's always the opposite of that sign. That would be the c. So if the sign is negative, the c would be positive. If that sign was positive, this would be negative. Since that's negative, the c would be positive, and that you put here. Okay, so that's the step. This is the c. Now the second step would be to bring this 2 down here. Once you bring that 2 down, the next thing you need to do is multiply 3 times 2, and then you're going to put that value here. So 3 times 2 would be 6. Okay, after you do that, you're going to add these numbers because you're adding here. Let me put it here. You're adding these numbers vertically. So -1 plus 6 would give you +5. And then after that, you continue doing the same thing. You multiply 3 times 5 gives you 15, and then you add. -13 plus 15 gives you +2. Continue doing the same. 3 times 2 would be 6. 1 plus 6 would be 7. This is your remainder. Alright, so this is not the final answer yet. We still need to interpret this and build a polynomial using these numbers that you got down here. Okay, so this is why I need you guys to think. You always, so that 2 will be the coefficients of the new polynomial. That 5 is the same, and that 2 and that 7. So these are our new coefficients, like these ones, of the new polynomial. And it's always one less than the one you started with. If you guys remember long division, you always started, for the most part, you always started on the second term of the polynomial, and that's where you would put the quotient on top of that. So you never had something above the first term here. So what does that mean? This coefficient would be the first term of the x squared. So you would have 2x squared, one less than the one you started with. So 2x squared, one less than the one you started. I'm repeating. So plus 5x, and you follow these symbols here. Plus, plus, plus. Sometimes you might get a negative here. Plus 2, that's it. You have the constant. So remember what I told you before. When you get a remainder, you're going to put plus 7 over the divisor, which is this. Not just a number, the whole thing. X minus 3. And you arrive to the same answer without doing long division. Okay, so let me do example 2. So again, make sure everything's in descending order. I forgot to mention that for those two. So identify the C. This is X plus C. So C would be the opposite of whatever you have here for that sign. So C would be -2 for this one. If you notice, that was minus, so C was +3. In this case, C would be -2 because that's positive. Make sure everything's in descending order. 4, 3, 2, 1, and then the number. So we're good. So now identify the coefficients. So 1, -2, -11, +5, and 34. And then what's the divisor? -2. Okay, so we have it set up. Now bring down the first coefficient, the first number, like that, and then multiply like that and put it here. -2 times 1 would be -2. And then add, like that. -2 plus -2 would be -4. So you see how we're getting negatives now? It used to be everything was positive here. Now we're getting negatives. So -2 times -4 gives you +8. You still have to apply the rules of mathematics, right? Negative times a negative, positive. And then add -11 plus 8 would give you -3. And then again, -2 times -3 would be +6. And then 5 plus 6 would be 11, positive. And then -2 times 11 would be -22 here. And then add 34 minus 22 will give you +12. So these are the new coefficients of our new polynomial. And it does have a remainder. This is a remainder. I would put a box that way you don't forget this is a remainder. And then let's build the new polynomial. So remember, it's always going to be one less than the original. So that means we start with x cubed for this coefficient. So, and I'm going to put the number 1x cubed. And then negative. So you got to follow the signs. So -4, what follows? X squared. And then -3x, right? 3, 2, 1 is going in descending order. Plus, this is +11. Plus a remainder. So the remainder, you put it like that over the divisor, the original, which is x plus 2. And that would be your answer for example 2. So let's continue with example 3. So for example 3, they want you guys to find p sub 2. So this is function notation now. So that's the function p, and we're going to substitute 2 into those x's. And then they want you guys to use synthetic division. These two will give you the same answer, and let me show you how. So this is the remainder theorem. They're not that confusing. So 3 and 4 kind of deal with that. So first, let's find p sub 2. So p sub 2. So when you get function notation, the x, so the x, it's equal to 2 basically, right? And it's equal to this function here. So we're gonna substitute for the x. So whatever you have an x per parenthesis, and then substitute the +2 in it. And then compute, evaluate. So 2 to the third would be 2 times 2 times 2. So this exponent tells you how many times you multiply in the base. 3 times. So 2 times 2 would be 4 times 2, 8. And then times 2 would be 16. So this is, let me put it here. 2 times 8, this part would be 8. Minus 4 times 2 squared would be 4 plus 5. Okay, and then evaluate this. 2 times a would be 16. 4 times 4 would be 16 plus a 5. So this gives you 5. So that means p of 2 is equal to positive 5. So we just evaluated for p of 2 using that function. Now we're going to compare it to when we do the synthetic division, and we're going to see what's the same with these two things. Okay, so let's bring the polynomial. And there's going to be an extra step for this one. So, and it's divided by, I'm going to put the word divided by x minus 2 right here. So this is the x minus c, so that means c would be the opposite of that sign, it would be 2. So we got the c now. Now, you need to check if the dividend, so this is being divided by this, the dividend, it's in descending order like I said. If you notice, this goes from 3 to 2. From 2, we should have a 1, so we're missing the 1. So that means you're going to have to construct that here. Plus, put a plus, 0x1 and then plus 5. So now we have the complete polynomial in descending order. Now find the coefficients of each term. 2, negative 4, include the 0 and the 5. Here, what we're dividing by 2. So this is synthetic division. We're ready. Bring down the first number and then start multiplying. 2 times 2 would be 4. So negative 4 plus 4 would be 0. And then 2 times 0 would be 0. 0 plus 0 would be 0. 2 times 0 would be 0 here. So that's how it goes. Every time you multiply like that, it goes here. 5 plus 0 would be 5. Okay. So if you guys notice, when we evaluated for pizza 2, we got a 5. And look, our remainder is the same as evaluated by 2. So we evaluated by 2 here. This would be that x. And we get the remainder 5. Wow. So just this is really neat. I just wanted to show you how they relate. So for this one, I don't think they want you guys to put the polynomial. They want you guys to see that connection when you're evaluating to the usual way when doing function notation. That the number we get when you do the synthetic division, you end up with the remainder, which is the same number that we got here when we evaluate by 2. And look, the 2 is right here, the 2 is right here. Maybe this is not the best example because we have a 2 and then we have a 2 here. They should have made another example. So let's do example 4. Example 4. So again, this one, use the remainder theorem and synthetic division to find piece of 4 if. So that's the polynomial. So you're dividing by piece of 4. Our divisor divided by would be x minus 4, right? Because that's a positive, so that means it's going to be divided by x minus 4. All right, so let's use first. Let's use Let's evaluate piece of 4 first. See what we get. So 4 to the 6th power, 25th, 4 to the 5th power. And as you can see, that's why they want you guys to use synthetic, because when dealing with big numbers like this, it gets crazy. So I'm not gonna do every individual thing, but if you calculate this in your calculator, if you go through all of these steps, you will get 16. So a piece of 4 gives you 16 if you evaluate that. Now they want to see if synthetic division will give you that 16 again. So now we're gonna do the synthetic. So based on the remainder theorem, we should get this number. Alright, so synthetic division. So let's write this polynomial in descending order first. For x minus 25x to the 5 plus 35x to the 4 plus 0x to the third, right? Because we're missing an x to the third here. And then that one follows 17x squared. And then we're missing x to the 1, so we're going to put 0x. And we don't have a number at the end, so I'm going to put a 0. So we're missing the number, so I'm going to put a 0. We're missing an x to the third, an x to the 1 after this, and then the number that goes at the end. Like this one, let me show you. So we're missing that number at the end of the polynomials, like this one. So that's why I have an extra 0. So those would be the numbers, the coefficients. So put them like this: 4, negative 25, 35, 0, 17, 0, and 0. Our c, so this is x minus c, so our c would be 4. Positive 4, right? If that was positive, as a divisor would be minus 4, because that's positive, so it's opposite. As a c would be the opposite of that, which is positive 4, like this one. Okay, so bring down the 4, and then start multiplying. 4 times 4 gives you 16, negative 25 plus 16 would be negative 9. 4 times 9 would give you negative 36. 35 plus negative 36 gives you negative 1. 4 times negative 1 gives you negative 4. 0 minus negative 4 will give you negative 4. 4 times negative 4 gives you negative 16, and that equals to 1, right? 17 minus 16. 4 times 1 gives you 4, so this would be 4. 4 times 4 would be 16, and this would be 16. So that's the new polynomial, but they don't want the polynomial. They just want you to use the remainder terms and synthetic division to find piece of 4. So I did it the old way. So this is when you evaluate normally. Maybe put a note here. Using synthetic division, this would be what they want you guys to do. So instead of doing these huge numbers, you can do this and you end up at 16. So this is a remainder. So based on that remainder, you can say that piece of 4 is equal to 16. So this would be easier than that in many cases because of the big numbers. That's it, guys. Thank you.